How much energy does interstellar space travel need? Have you ever wondered how much energy it would take to travel to another star? The answer is astonishing and shows just how far we are from interstellar travel. To reach even the closest star, a spacecraft must travel at a significant fraction of the speed of light. This requires an enormous amount of energy, far beyond what our current technology can provide. To put this into perspective, estimates suggest that interstellar travel could need around 140 quadrillion kilowatt-hours of energy. That is an unfathomable figure. To generate this energy, we would need to annihilate over 5.6 million kilograms of matter, converting it entirely into energy. This amount is roughly 14 times the mass of a fully loaded large aircraft. But that is just the beginning. The energy calculations do not even account for the additional fuel mass needed to accelerate both the spacecraft and its fuel. This could increase the required mass by a staggering factor of about 1,400 times the spacecraft's original mass. Clearly, these energy demands make interstellar travel seem impractical with our existing methods. Several propulsion concepts have been proposed to tackle this challenge. For instance, nuclear pulse propulsion and fusion rockets are on the table. Another exciting idea is beamed energy propulsion, which involves using powerful lasers to push lightweight probes to speeds close to the speed of light. Such systems might require power levels in the tens of gigawatts, similar to the power output of the space shuttle's main engines, but used in space. While these technologies are still in the theoretical or experimental stages, they could significantly reduce the mass and energy requirements compared to traditional chemical rockets. However, the extreme energy needs of interstellar travel highlight why it is currently beyond our reach. Astronaut training today focuses on missions within our solar system, where energy demands and travel times are manageable. For interstellar missions, astronauts would need life support systems capable of sustaining humans for decades or even centuries. Concepts like generation ships, where multiple human generations live and die during the journey, are also being considered. In summary, interstellar travel requires energy on a scale millions of times greater than what we currently use for space missions. This means that astronauts are training for long-duration missions, but actual interstellar voyages remain as a challenge that will need new technologies and mission concepts to become a reality. The future of human spaceflight is bright, but we have a long way to go before we can reach the stars.